We are going to solve the problem using Fredholm first theorem, right? So find Eigen value. Just we are going to find the Eigen value of the integral equation g of s minus lambda integral 0 to pi sin s plus t g of t dt equal to 0. So given equation g of s is equal to lambda into integral 0 to pi, right? We are taking that side, right? G of s is equal to lambda integral 0 to pi sin s plus t g of t dt, right? That is equation number 1. Here the kernel k of s comma t is equal to sin s plus t, and h is equal to, we know that is the formula b minus a by n from the first theorem, right? Fredholm for first theorem, we are using all these ideas, we are taking from that, right? H is equal to b minus a, upper limit minus lower limit by n. We are dividing that interval ab into n equal intervals, right? That is what b minus a by n. So pi minus 0 by n, pi by n. So n, we need n value, then only we can split the integral, right? Otherwise there are n intervals are there, right? If you are taking n, then it is very difficult to calculate. So that is why for our convenience we are taking n is equal to 3, right? Therefore h is equal to pi by 3. This is easy for us, right? So s1 equal to first interval, s1 equal to t1 equal to a, s2 is equal to t2 is equal to a plus h, s3 equal to t3 is equal to a plus 2h. Substituting the value, a is equal to 0, right? Because a is the lower limit, a is equal to 0, s1 equal to t1 equal to 0, s2 is equal to t2 is equal to pi by 3, s3 is equal to t3 is equal to 2 pi by 3, pi by 3 plus pi by 3, right? A plus 2h, otherwise 2 into pi by 3, right? We know that k of si comma sj is equal to kij, I is equal to ij is equal to 1 to n. So kij is, these are all results from the theorem, right? We are taking that one. Kij is the determinant k11, k12, k13, k21, k22, k23, k31, k32, k33. But k11 is nothing but, if you are putting k11 mean, that is the notation, that is k of s1 comma s1, k of s1 comma s2, k of s1 s3, k of s2 s1, k of s2 s2, k of s2 s3, k of s3 s1, k of s3 s2, k of s3 s3, right? So we know the value of s1 s2 s3, substituting the value k of 0 comma 0 determinant value, right? K of 0 comma pi by 3, k of 0 comma 2 pi by 3, then k of pi by 3 comma 0, k of pi by 3 pi by 3, k of pi by 3 2 pi by 3, k of 2 pi by 3 0, k of 2 pi by 3 pi by 3, k of 2 pi by 3 2 pi by 3. So k of s comma t we know, right? That is sin s plus t, right? So k of s comma t, put s is equal to 0, t is equal to 0, first value, right? Sin of 0 plus 0, sin 0 within determinant. Next 0 plus pi by 3, sin pi by 3, 0 plus 2 pi by 3, sin 2 pi by 3, then pi by 3 plus 0, sin pi by 3, sin pi by 3 plus pi by 3, sin 2 pi by 3, sin pi by 3 plus 2 pi by 3, 3 pi by 3, that is sin pi, then sin 2 pi by 3 plus 0, sin 2 pi by 3, sin 2 pi by 3 plus pi by 3, that is sin pi, sin 2 pi by 3 plus 2 pi by 3, right? So sin 4 pi by 3. Substitute the value of all the values, sin pi by 3, sin 2 pi by 3 from the table or calculator, right? 0, determinant value 0, 0.866, 0.866, same value 0.866, 0.866, 0, 0.866, 0 minus 0.866. So we know, next we are taking the formula from the theorem, dn of lambda is equal to 1 minus lambda h k11 minus lambda h k12 within determinant, right? We are writing all this, minus lambda h k13 minus lambda h k21 minus lambda h k22 minus lambda h k23 minus lambda h k31 minus lambda h k32 1 minus lambda h k33. We know the value of h, right? H is pi by 3, right? And k11 we know, right? K11 value is there already in the above determinant, right? K11 is 0, right? and k12 value is there, right? So everything already there, so substitute those values. So 1 minus 0.907 lambda, minus 0.907 lambda, minus 0.907 lambda, 1 minus 0.907 lambda, 0, minus 0.907 lambda, 0, 1 plus 0.907 lambda. If dn lambda equal to 0, right, we know the homogeneous system will have non-trivial solution. So put dn lambda is equal to 0. So the determinant value, we already have the determinant that is equal to 0. So normal determinant, solving the normal determinant, right, 1 into, right, other two rows, right, you are taking 1 minus 0.9011 lambda into 1 plus 0.9011 lambda, then minus of minus 0.90 lambda into minus 0.90 lambda into 1 plus 0.90 lambda into 0, then last row, last element, right? So if you are solving this, we will get 1 minus 3 into 0.0907 square lambda square. So taking that to that side, lambda is equal to, right, so lambda square is equal to so you will get 1 by 3 0.0907 square, that is plus or minus 0. So lambda square value, right? So lambda is equal to plus or minus square root of that value, so you will get plus or minus 0.6365, that is the eigenvalue. Lambda 1 is 0.6365, lambda 2 is 0.6365, right, which are the eigenvalues. Thanks.